Where am I? Here I am. Okay. Firstly, this isn't the... I was going to write with that. That wouldn't do anything. A1. Sorry. A 2 microfarad capacitor is charged to a potential of 100 volts and is then connected in parallel with an uncharged 4 microfarad capacitor. So part 1, determine the charge in the 2 microfarad capacitor. So look here. Here's your capacitor, and what's the formula? It's in the formula book. It's Q equals, not that one, the other Q one, CV. C is 2, and V is 100. So it equals 200, but be careful, this is micro coulomb. And if you want to convert it to coulomb, just divide by 1,000. Don't confuse me now. Divide by 1,000. Yes.
What's by 10 to the minus 3?
Yeah, micro is 10 to the minus 3, so multiply by 10 to the minus 3, and you will get anyways. This will be the answer: 10 times 2 to the minus 4 coulomb. Although this is fine, I'd still give you full marks for this. 200 microcoulombs, okay? How many marks for that? Well, I think that's only 1 mark. Okay. He then says you connect this capacitor with another capacitor like this. Does he? No. He says they are parallel. So they're like this. There's one here, and there's one here. Parallel. Okay. Now, at this capacitor here, I'll put this big one on the top. This is a 4 micro, and then this one here is the 2 micro. Does anybody remember how the capacitors combine when they're in parallel?
It's the same.
No.
You got cut out. It's the opposite.
Yes.
So they add.
Yeah.
So the total will be 4 plus 2. So 6 microfarads is the total capacitor. Now, hey, come on, focus here. We calculated the charge at this one here. What's the charge here? It's 2 times 10 to the minus 4. I'm doing number 3. Please focus. Please focus.
Number 2 was the adding. The final potential difference.
No, I'm working at that still. I'm still trying to get that. So, here, please, hang on. Okay, can we all just please focus? In part 1, I calculated the charge in the capacitor. What's the charge here? 2 times 10 to the minus 4 coulombs. Got it?
Yeah.
Right. Now, I take my charged capacitor and I put it with one that's not charged. What is the total capacitor for this system? 6. Now, what's the formula? Q equals CV. And what does he want? He wants the V. So V equals Q over C. Now, this is where you have to think carefully. I know the C, but do I know the Q?
Yeah.
I do, because this is charged with 2 times 10 to the minus 4. And I don't really care if some of the charge goes into this, or if it all stays here, or whatever. Whatever charge I put into the one capacitor at the start, that's how much charge I'll have in the whole system. I'm not going to get more or less charge. Okay? So in fact the Q is 2 times 10 to the minus 4, and the C is 6. So the volt, please calculate, it'll be like 0.33. So actually it'll work out as 33.3, I think,
Yeah.
volts. Yeah?
No.
Oh, sorry, wait. Whoa. Let's all be cool. I forgot that this is micro.
Yeah.
So actually this is 10 to the 6. There we go. Now, we all cool?
33.3.
We're all cool. Right. Part 3. Part 3 is calculate the energy in this system. Now, I think the formula is in the book, but does anybody remember it off the top of their head? It looks a lot like the kinetic energy formula. There's a half in it.
Half CV.
Half CV squared.
Oh, that's one, yeah, and I think there's one with Q in it too.
Q.
We could use that one, a half CV
No,
squared.
that's W.
Yeah, but it's the same thing.
Yeah.
Yeah, we'll use that one. A half CV squared. We could say a half CV squared. But, hey, look here. That's in the formula book, right? But we could also say, what does Q equal? CV. So if I wanted to get rid of like the C or the V, I could. Now, let's think about this logically. What do I know? I know the Q, don't I? And what else do I know?
C.
I know the C. What else?
The V.
The V. I think I mean, you don't have to. I think I can just use this. But if you need to change something, you could use this one. So anyways, what's the C? It was 6, didn't we?
Yeah.
6 times 10 to the minus 3. And what was the V? Did we get the V? We did. 33 point... Oh, sorry. Minus 6, because it's micro. 33.3, wasn't it? Okay, what's this equal to?
9.99.
It should be quite small.
9.99 times 10 to the power minus 5.
Yeah. Oh,
Oh.
3.32
thank you.
3.32. Yes.
times 10 to the minus 3.
Yes.
Times 10 to the minus 3 joules. And what's minus 3? If I wanted to give it something, what's minus 3? Milli. Yeah, so if you wanted, you could say it's 3.33 millijoules. How many marks so far? 6. It's okay, I think. Yeah? Now the next one. If the capacitor is allowed to discharge through a resistance of 5 mega ohms. How big is mega?
6.
It's 10 to the 6, isn't it? Yeah. Right. Sorry, that's mega ohms. Determine the time taken for the potential difference across the combination to fall to 10 volts. What's the voltage at the start?
100.
What is it? 100, very good. And what's the voltage we want? 10 volts. Now, there is a formula. I don't know if it's in the formula book, but it's the, if you look in it, we'll see, I'll show you which one it is. It's the one with the E in it. It's looking bad for you guys. Oh wait. It's not there. Okay, so this is one not in the book. You need to. I don't know if anybody remembers it, but it's the formula when you have a capacitor. What happens to the voltage when the capacitor discharges? It decreases. Do you remember the curve? It's like pretty quick. The formula is this: voltage equals voltage at the beginning, e to the power of minus t. What's t? Time. And who remembers what's on the denominator? Or C. Not in book. Please learn this.
Yeah, that's not the book.
Yeah.
There is.
But I think the RC is in it, is it?
There is like T equals RC.
Tau equals RC, yeah. But this particular one you need is not. Okay, let's fill in the information. What's the V here? Come on, wake up.
100.
No, this one, 10. This one,
100.
100. The T, we don't know. We want the T, the time. The R,
5.
and the C,
6.
okay, we need to, oh, well, that's nice because that will cancel that. So 5 times 6, 30, and then that can go over there. So I get 0.1 equals e to the minus t over 30. What to do next? Log, so that's gone. And I bring the 30 up here. And then what to do with the minus? Take it over here. So the time is this, minus 30 log 0.1. Which turns out to be 36.1 seconds.
69.07.
You are pressing ln on your calculator.
Yes. Definitely.
Minus 69.
69. Not minus. 69 only. You put the minus in front of it, and then you calculate just 69.
What is the answer?
69.1.
I wonder if they made a mistake. T equals minus or C times. I think they made a mistake here. No, who told me 100 volts? That's the mistake.
Aziz.
No, it's an understandable mistake. The voltage at the beginning is not 100 volts. It's the voltage when both capacitors are connected together. What was the voltage when you connected both the capacitors together? We got it earlier. Where is it? 33.3. So, hey, at least he's trying. Instead of just sitting in the corner laughing.
What?
What? Can you fix this, please? It should be. So instead of 0.1, it is. What is 10 over 33.3?
0.3.
No.
0.300. 0.003.
10 over 33 is about.
Your final answer is 0.30.
0.3.
Shh.
Am I kidding over here?
Yes, you have.
No talky talk, please.
0.300.
Thank you, Bilal. 0.3 will do nicely. Now, give me the T is minus 30 log 0.3. 36.1 seconds, we'll say. So, sorry, just to make it clear, what happened here is you have the two capacitors, you connect them together, and what was the voltage? 33.3, and then you let them discharge down to 10. No, in this one was the 10 volts. Yeah. Okay. Now, next one. Yes.
The calculator is different between log and
Yes, use ln only. In physics class, you should never be using the other one. Electric field strength. Give me the definition. Well, who can remember the formula for it?
E equal I over Q.
No. F equals QE was one formula, wasn't it? Actually, if you don't know, look at the formula book and see which ones you can remember to see. So if you look, yeah, there it is on page 4 in the middle. E equals F over Q. Yeah? So what's happening here is, it's usually something like this. You have your two plates, and you have a little charge inside it, and the charge is pushed by this electric field. And E tells me how strong the field is. So, Who would like to try and give me a definition using this formula? So, electric field strength E. First, it tells me how strong something is, but how could you rephrase it? Well, what unit is force? Newtons. And charge coulombs. So, for example, let's say E equals 2, and let's make it easy. Q equals 1. So E equals 2 and Q equals 1. So what will F equal? 2. Yes? If E equals 3, F equals 3. So in other words, you can see now, per coulomb, the bigger the E, the bigger the force. Yes? So, we can say something like this. Well, let me give it here. Yeah. I'll just write E, electric field strength for short. Electric field strength is the force per what? Yeah, per unit coulomb.
Coulomb charge.
Yeah, coulomb charge, thank you.
No, something.
Wait, chill. I won't, no, I don't want to write the word coulomb because I didn't write the word Newton. Electric field strength is the force per unit charge. That's really it. It's the force per unit charge. I should, hey, please. I should also point out, how many marks for this? 2 marks, is it? The electric field strength is the force per charge. But it's also important to say is that the force is in the same direction as E. So if the electric field is going in one direction, then the force has to be going in the same direction. Okay, you couldn't have something silly like the electric field is going this way and the force is going that way. Is that okay? Alright, I hope so. B part 2. Where's it gone? Oh yeah, I don't know if you remember this, but part 2 is sketch the electric field around a negative charge, like for example an electron. So which way does the electric field go? Well, think about it. What way does your current go in your circuit? From positive to negative. So should the lines be going into this or out of the yeah, it should be going into. So in other words, if they ask you to draw the electric field around a electron, it just looks like this. That's the electric field. As simple as that. 2 marks for that. And if you want to just make it extra clear, here is the positive and then here is the negative. So these are all positive. Simple. Okay, next one now. Now the last part of this. Now this one here, please be very careful with it. I'll draw it now. So he has 4 charges together. Charge A, charge B, charge C, and charge D. And it's in a square. And the square is 5 times 10 to the minus 2 meters. Now, for part 1, he wants you just to look at the electric field for A and C. So for the moment, let's just not imagine the B and the D here, okay? We'll just look at A and C. This is positive or negative. What is the charge here? Positive. And here, also positive if you look at it. It's 2 microfarads. And then here, oh sorry, microcoulombs, of course, because it's charge. And then here, 6 microcoulombs. Now, what direction will the electric field be going around this one? Into or out of? Out, very good. So it'll be going like out. And then this one here? Out as well. Yeah, so if you look here, this one is going out, and then this one here is going out as well. We need to calculate the distance between them for our formula, so I'll just delete these lines. We don't need them, but just so you can picture, they're both going out, okay? Now, how can I get the distance between these two? Well, what you can do is draw a triangle. And here is the hypotenuse, and here are the two sides. So I can use the formula 5 times 10 to the minus 2 squared plus 5 times 10 to the minus 2 squared. What should that equal? It should equal r squared. You know what I'm doing here, don't you?
Yeah, right there.
Pythagoras. I'm doing this side and this side because I know each of these. Now, when you calculate out the r, you'll get, what will you get?
0.07.
Are you sure? Oh yeah, okay. I would actually like you, for this one, to divide your answer by 2, so we can do this piece and this piece separately. Okay, so just divide your answer by 2.
0.035.
So I'll call the whole thing big R. I'll show you why now in a moment. I actually want these small ones here. So I get, that's big R. So I get small r equals, the answer is saying 1.25 times 10 to the minus 4. What? Do you want to check? Do you want to check that? Is that right or wrong?
Wrong.
Do you have your calculator? So what did you get?
5 multiplied by 10 to the power minus 3.
5 times 10 to the power of minus 2,
Minus 3.
and then square. Yeah, what did you get, Brandon?
0.071.
Yeah.
And then divide by 2?
0.035.
Yeah, that's what I got as well.
These two.
I think they're answering.
Maybe you wrote something wrong over there.
Did I draw this right?
Did you put the root in the answer?
Yeah. It is a square, isn't it?
Yeah. Yeah, did you put the root?
And, oh no, wait, no, it is right, sorry. This here is this side, yes? Fine. And then this here is also this side, yes?
Yeah.
So this squared plus this squared should equal this squared, yeah?
Yeah.
Did you get the same answer, Omar?
Mostly yes, yes. But is it 5 times?
No, 0 divided by 0.005.
Yeah, 0.035.
I guess maybe it's their mistake. They got 12.5. Let me double check what they did. 25 divided by 2 times 10 to the power of minus 4. Square root answer. Oh, Their mistake. Cool. The funny thing is, none of my students did this question, so that nobody cares. Yes. Okay. So R equals not this. It is
0.035.
0.035. So 0.354 meters. Cool. Okay. Now, if you look at your formula book, go to page 4. Now, he wants you to calculate the electric field strength. How many formulas do you have for electric field strength? No, look. How many formulas do you have for electric field strength? You have 3. What are they?
E equals to FO.
Alright, let's take these one at a time. E equals F over Q.
Yeah.
Do we know the Q?
Yeah.
Yes, we know the Q, the charge. Do we know the F? No, so no good for us. E equals KQ over R squared. Do we know the Q?
Yes.
Do we know the R?
Yes.
And do we know the K?
Yes.
Well, it's a constant, so we know it then. It's given and beside it. And the last one, E equals V over D. Do we know the V? No. Do we know the D? Well, we have the distance. So which formula do we need to use?
The middle one.
The middle one. So he wants it, let's do it for each of these. So this one first and then this one second. Okay. So firstly, E equals K Q over R squared. K equals, I'll write down the constant K for you. It's 1 over, oh actually it's in the start of the book, isn't it? Yeah, it's 8.99 times 10 to the 9. Okay, what's the Q for the first one? That's a 9. That's a 9. What's the Q for the top one? It's 6, isn't it? So 6 times 10 to the minus 6, and then what's the R? It's 0.0354. Okay, can you calculate that, please? Yes. You did that on purpose. You knew I said it was a 9. 8.99. All right. Now we write focus. Okay. Did you get an answer? 43043,186. And what's the unit? Newtons per coulomb.
Squared. No.
No. It just remember from the definition, it's force per charge. Remember?
Yeah.
Up here?
Is this?
But isn't it R squared?
Yeah, but I mean, you can rewrite the units using this, but this is the easiest one to use. Let's clean this up a bit. So that is about 4.3 mega.
No, 43. 43 mega.
Yeah, 33.
43?
Yeah.
Are you sure?
Yeah, 33.
43 mega.
It's 4.3 times 10 to the 6, yeah?
No,
times
43 times 10 to 6.
How much centimeters are
43.
Or 43 mega.
Oh, sorry. I miscounted I should have put that there, shouldn't I? Thank you. 43 times 10 to the 7 newtons per coulomb. Now, focus, people, focus.
It's 6.
1, 2, 3, 4, 5, 6. Thank you. Now, we have to do the same thing, but for this one, the only difference is it's 2 instead of 6. The Q. Yes?
Because it says magnitude of direction.
I know, I'm getting to it. Okay? I'm doing the first one, then I'll do the second one. And then I'll get that.
So what is this?
No, but wait, I'm getting to it. So, divided by, can you calculate that please? Except it's 2.
14.35 times 10 to the 6.
Yeah, that's for the A, and then for the one down the bottom, the C. What did you get?
14.35.
Huh?
14.35.
14. Are you
times
sure?
10 to the 6.
Yes, okay, I'll believe you. Say it again. 14.
0.35 times 10 to the 6.
10 to the 6 newtons per coulomb. Now, that is the electric field at A, the strength. That is the electric field at C, the strength. Tell me, do you think you add them or subtract them when you put the two together?
You add them to strength.
Yeah, what do we think? Add or subtract? Now, I'll give you a little hint. This one, it's going this way, and this one here is going this way. So now, add or subtract?
Subtract.
We're all agreed it's subtract. Because the electric fields are going in opposite directions, they'll subtract from each other. Okay? Right, so when you subtract these, you get electric field strength 43 minus 14.35. What's that?
28.65.
What is it?
28.65 times 10 by 6.
Now, Omar, that is the magnitude. He now wants the direction. So what will the direction be? So the question is
Right.
it
Right, so
C to A.
is it A to C or C to A? Which will it be?
C. A to C.
Correct. It'll be A to C. And the direction is from A to C.
That's it.
That's it. Now, what I think is really strange is in part 2, if you look at part 2, he asks you the exact same thing, but from B to D. And what's even crazier is look at the marks.
2.
And what was the marks for the last one?
3.
The only reason I can think of him giving you one less mark is because you already just did it. So the only thing you have to change are the charges. So instead of having 6 and 2, we now have minus 8 and minus 4. Okay. So let's do the B one first. So it will be 8.99 times 10 to the 9. That's the K. And then what's next? The Q. What's the Q? Minus 4 times... Well, actually, we won't worry about the sign just yet. 4 times 10 to the minus 6. And then the distance is 0.0354 squared, and then while you're doing that, also get the D as well. Which one are you giving me, Brandon?
The first one.
Okay, what is it?
1.016, like that.
1.016. Yeah. Times 10 to the 6 newtons per coulomb, and then the other one, please.
What happened to the sign?
When he uses the word magnitude, he wants the size, not the sign, just the number. Then we'll worry about the sign later.
Sorry, the first one was the first one was 28.7. 28.7.
28, just 28.7.
Times 10 to 6.
Okay, and then the next one, It should be bigger. Should be twice as big, shouldn't it?
57 times 10 across.
Are you saying 57 because you have 57, or are you just guessing? Is it exactly 57? No, 57.4. Now, let's go back to this one. So which way does the arrow go at B? Well, is it positive or negative charge here? It's negative. So which way is the arrow going? It's going to it, isn't it? So it's going like this. And then what about this one? The same. So do we add or subtract? Subtract. They're still going in opposite. They're going in opposite directions. So can you subtract these two together? And then we get the one from B to D.
28.7.
Oh yeah, because one is just twice the other, yeah. Now, time for the direction. What do you think it is? D to B? B to D? What do we think?
B to D.
Right.
They're going in the opposite direction of each other.
This one here is the B, and this one here is the D. So which one is the bigger one?
No, they say.
Wait. No, we'll just worry about this for a moment. Which arrow, which is the big, stronger electric field? This one or this one?
B. B.
This one.
Stronger.
I don't care. Wait. I don't care about the sign. Forget about the sign.
Okay.
Which one's bigger?
D.
This one here. Okay. Will this add or subtract to it? Subtract. So I'll make this smaller. But it's going from here to here. This is going from positive to negative. Okay? So here is the positive and here is the negative. So when we give our answer, we should give it from negative to positive. Okay? You're looking all confused at me, like, what is he talking about? Maybe I'll draw it down here for you. Okay, so this one is going here, and this one is going here, yes? Which is bigger, blue or red? Blue. Now, rather than thinking of the blue here, I can just move it up here. And I can move the red down here. They're going in opposite directions, aren't they? So when you put them together, you subtract them. No, actually, I realise this isn't going to make it easier for you to understand. Alright, let me put it this way. Here is my electric field, and here is the positive, and here's the negative. So here is positive to negative, and here is negative to positive. Yeah? Which one do I say is the direction of the field?
From positive to negative.
Well, it seems that the convention here is to say negative to positive. So if I know where the negative is and I know where the positive is, I say it goes from negative to positive. Okay?
So negative is D.
So in this one here, no, I know both of them are negative, you're right. But when you add them together, it's like this one is, or when you subtract them, this one's gone and this one is like it gets smaller. So the positive is here and the negative is here. So negative to positive would be that way. Look, it's 1 mark for getting the direction right. So you got a 50-50 chance, okay? B to D. And the other one was, where's it gone? A to C. The last part, now it sounds difficult, is to put all 4 of them together. But don't panic, because we've already added them together. A B, C, and D. Okay, what did we do first? A to C. And which way was the answer pointed?
From A to C.
So it looks like this, yes?
Yep.
And what was the answer? Can you tell me what it was?
20.65.
What is it? 20.65.
28
28.65. What's the
times 10 to 6.
and it's newtons per coulomb. And then what do we get for the other one?
EVD.
B to D. What are you talking about?
Yeah.
What?
Yes, Omar.
From B to D.
Yeah.
I said EVD. As in EVD.
Omar, leave it.
That's the direction I'm talking about.
B to D.
Yeah, sorry, I've been an idiot. I said it went this way. Don't look at me like that. It's gone B to D. Because which one's bigger?
Yeah.
This one.
Yeah.
So when you take this away, which one's still bigger? This one. Yeah. So I'm sorry. I've been an idiot. Just ignore this, okay? What's that, Donald? Well, I still wrote B to D here. I was right, but I gave you the wrong reason. It's B to D because that's the bigger of the two. Yeah? Well, whatever. Alright, how big was B to D?
28.7.
28
0.7 times 10 to the power 6.
newtons per coulomb. Okay. Now, you want to add these two together. Look carefully. If I break this one up into this piece and this piece, and if I break this one up into this piece and this piece, what happens here?
Cancels out.
They cancel. So you only care about this one and this one. Now, what angle is here?
90.
No, this one here?
Oh,
45. So this piece would be 28.7. I won't write this in just to save space. Times cos 45. And then likewise here, what's this one going to be? 28 point, no, it'd still be cos 45. So take these two answers, please, and just divide them by root 2, because that's cos 45. And tell me what you get.
The first one is 40.35.
Yeah, just add them together. Come on, dudes, we want to go home. Give me the answer here. Here, come on, get working.
40.55.
40.
55.2573.9.
I need a second. So 4 here, yeah?
40 times 10 to the power 6.
Agreed?
Agreed.
Now, last part is the direction. Now, wait. Let's all be cool here. What's the direction going to be?
Down
It's D to down.
Yeah, what letters? Give me letters.
from A to D and B to C.
Yeah, he's right.
You want to object on me?
He's right. It's these ones cancel, so you just have the two going down.
Yes.
They add together.
I'm still going to the right of it.
No, because oh wait, these two aren't quite the same, are they?
So we're going to.
They cancel.
Oh wait, we said they cancel, but they're not equal. They're a little bit different. Okay, we have to subtract these actually. Chill. Yeah, just if you have this up on your calculator still, just put a minus between these.
Minus between what?
So this is the
The same number.
down piece, and then we want the piece going across this way.
So
So just subtract them.
it's 35.
50,000.
Actually, hang on, no, don't. Look,
35.
no, look, this is 0.7, yeah? How many decimal places? 1. If we round this off to 1 decimal place like we should to keep them the same, what would it be here?
Same thing.
7. So yeah, no, they do cancel. No. Guys, my advice is we need to be careful with our decimal places. If we're going to do 1, then we need to do 1 for all of them. So I don't think that will make much of a difference to this answer. Well,
Just nice.
might go up a little bit because there's a 5 here. So what's the direction? From A to D. You're right, Brandon. If they weren't exactly the same, then it'll be a little bit to one direction. Oh man.
What? Shut up.
Never mind.
Like you only stuff them.
If anybody finds that funny, I know who likes One Direction.
What are you gonna mean? I don't know.
Yeah, you.
Yeah, sure you know.
Sure.
Believe you.
Just before I finish the recording here, for the record, Alex likes One Direction.